Right, so I thought I'd talk about something a little bit different. We've had lots of talks about more traditional HPC and some performance aspects. So I'm going to talk about how we can build user interfaces for HPC and how we can allow people to access these things fairly transparently. So this is potentially a typical text-based interface that we use for HPC. Most people, I suspect, probably use it in this way. There are other text-based interfaces that we can have that are quite neat, but in general, they usually have pretty steep learning curves. Yeah, sure, we can sit down and show people how to do this, but if there may be master students that are coming through or external collaborators, sometimes we wish that there were easier ways for them to do this, to have quick learning curves. So what I'm going to talk about today is how we can go from something like this to this sort of workflow, where maybe we're parameterizing a small problem, or maybe we're parameterizing a particularly difficult problem. What's involved in being able to construct these sort of interfaces relatively quickly and relatively easily. And then I'll show you some work that we're doing, or some work that we've extracted from some of our projects to enable this to be done done significantly quicker than the traditional methods. So here we can see some kind of workflow where I'm clicking new, I have some window that pops up, it allows me to configure my application in some sort of way. I click OK, it gets sent off to the cluster and it appears in some sort of queue locally. So the idea here is that I'm abstracting away the interface of submitting jobs so that the user isn't aware of all of the complications happening behind the scenes. So the first way we could do this is we could build it ourselves. There's quite a lot to think about. There are little tricky areas. It needs to be fairly resilient. It needs to retain some sort of state somewhere. It needs to be multi-threaded. Ideally, we'd like it to be multi-cluster so that I can submit to maybe this cluster using this scheduler, another cluster using another scheduler, maybe to the cloud. Maybe I want to run things locally. So we'd like a little bit of flexibility there. So to achieve that is quite a lot of coding and probably time-consuming. It's certainly not an afternoon job. So the first aspect that we'd have to abstract would be the submission process to the cluster. Fortunately, there are some people who've done some really, really good work on these kind of workflows. Parcel is a fantastic library that we're starting to use now. It abstracts lots of different types of workers. So clusters, cloud services, you can run on your own machine. You can run locally submitting to another machine, or you can run on another machine submitting to its own queue. It's a very, very flexible approach. It's developed by Chicago. It's developed in the US. It can run on, as I said, it can run either on your desktop or on the cluster machine submitting to the queue. And it gives you some really easy mechanisms to abstract away the process of submission and parallelism using features. It can also handle MPI or either MPI or serial jobs, and it does them in lots of clever and flexible ways. So it really is a great tool. I'd recommend you have a look at it. Quite actively developed, and the idea, the way that it works is rather than constructing some a priori graph of the way that of the flow that I expect my program to have, or the jobs that I'm expecting to submit, it will construct that graph at runtime based on some logic. So I end up writing some Python code, or because this library is in Python. There are ways to also submit bash scripts or shell scripts, etc. But at runtime, it will work out what it needs to do next based on some code that you've just written. And it will stop when it needs to stop, waiting for some results. Now, that could be useful for some of you actually as part of your workflow, if your workflow involves several steps that you're submitting to a cluster, or several jobs that you're coordinating. If that's not the case and you're just submitting one big batch, or one big simulation, it's still quite useful in abstracting away this interface and how we talk to the cluster. Running The nice thing about this, if you're writing all of your code yourself from scratch and you're writing it all in Python, is that running something anywhere on any machine or on any cluster amounts to me writing one function in my code and annotating it, saying this will run somewhere else. And all of the rest of it, all the file transfers, all the arguments, etc., are handled by the library. Quick example of how Parcel works. Here we see I've got two functions. I've got some expensive function at the top, which is the thing that's doing some work, and I've got also some expensive reduction, which is something that I want to happen to the results of multiple runs of this first expensive function. So the key thing here really is this expensive reduction function needs to wait on the outputs of the previous functions. But the nice thing is here that I'm just writing this out as if it was normal code. I say ABC equals the output of. This could be, if you've got multiple runs, this could be in some sort of loop. And then the dot result calls here are essentially the only thing that blocks. So it'll keep running, it'll keep figuring out what it needs to submit, it'll keep submitting them. And then when it gets to a dot results that it doesn't have yet, it'll say, right, okay, I need to wait at this point because the next operation, it knows implicitly that the next operation depends on the previous. It's quite simple, it's quite straightforward little tool to use. So that's the library on which we're currently building our framework, building our tooling on. That handles the submission aspect. The next challenge that we have is how to build a UI. So if you want to build a UI, one of the nice frameworks that are out there would be the Qt framework. Very popular, very, very widely used. The nice thing is that there's a C++, it's a C++ library, but there are also Python bindings that are equally easy to use. Very, very simple to infer what you need to do in Python based on the very extensive C++ documentation. It's object-oriented, and the idea here is that we place little widgets that could represent buttons or text fields or file buttons to access the file system, drop-down menus. And the idea is that I compose more complicated user interfaces based on a composition of these very, very simple building blocks. If you really, really need the ability to go off and build your own little building blocks, you can do that as well. So it's a very composable way of building a UI. And then these widgets fire some signals, which essentially you need to tell the library, right? This widget has just said I've been clicked on. This is what you need to connect the clicked signal to some action that you're going to perform, and it really is that simple. So you say connect clicked to do action, and do action would be a function. I realize this is very, very high level. You probably aren't going to be Qt experts or Parcel experts by the end of this, but the idea is to introduce you to some technology that maybe if you're interested, you can go off and have a look. So then all of the functionality gets handled in these event handlers. And here's the little slightly tricky thing, is that if you have anything long running, it should run in a worker thread. But the nice thing in our case is that we can allow Parcel to handle this, because Parcel also handles some degree of multi-threading. A simple example, this is a simple example of what we get. The nice thing, we get multiple platforms for free just by writing the same code. In Python, a very simple example looks like this. We build a widget, QLabel, we instantiate the app, and the widget will pop up. Similar code in C++. As you can see, the API is very, very similar, and it's fairly easy to build. This is some code that's from, appears not to be working. That's a shame. So the idea of this demonstration, this is some code that actually I worked on with Ben. And the idea here is, and what I was going to show you, that you can actually build some very, very flexible and fairly powerful ways of configuring applications like this. In this case, it would show a mesh. You'd be able to pick points of the mesh, drag buttons around on the screen, and create a very interactive, configurable way of operating. And then this could be put as a front end to the parcel library, and you could easily get some fairly simple to use tools for your users. As I said, Qt is very well documented. And this brings me on to Runner. So Runner is our framework that we're building around trying to make this process as easy as we possibly can so that we can do it very, very quickly for hopefully a number of users and get them to be able to provide easy access to their software on HPC. We've divided the actions, we've divided the points of customization into three things. One is, the simplest is the runner, which is just a function. The idea is that you use some library like Parcel to try and to make that to abstract that function. Some actions, so the idea is based on the outputs, we're going to be able to perform some actions. And the configuration view is the thing that you saw popping up. So if we, and all of that gets wrapped into a plugin. So an example of the code becomes very simple. The runner is a function. The configuration is done very declaratively, or it can be done completely custom, however you want, by passing in one of these widgets. And all we do is instantiate a plugin. So the idea here is that it's very, very simple, it's very, very straightforward, and it should be easily done in a very, very short period of time. I'm going to skip over this quickly because I'm a bit limited with time. So the conclusion is, hopefully, using some of these libraries, Parcel, Qt, etc., you can, if you like, if you have that need, build some very, very powerful and accessible ways for people to get on to use your software on a cluster, or for maybe students or industrial partners, etc., to very easily submit their jobs, very easily configure your applications. If you do need any help with that, if you want to have a chat with that, come and have a chat with me and ask any questions, and I'm happy to help. So that's me done. Thank you very much.
Thank you. We have time for one or two questions. Am I right in thinking that when you write a GUI in Qt, that then that's running locally on the local machine?
Yes.
Can you wrap that into a web browser? Because running things locally is a bit, in the past now, you should be pushing things to kind of, especially if you're not doing compute locally, if you're doing compute somewhere on some cluster, then a web-based approach surely would be more appropriate.
Yeah, sure. There are different approaches. I wouldn't go as far as saying that it's the correct approach now. Mm-hmm. It's an approach now, and yeah, also wrapping things in web UIs would also be a good way to go.
Yes, I guess my question is, if you've done that work in Qt, can you put that in the web browser system?
The Qt library doesn't instantly port over to web browsers. There are parts of the library that can be ported relatively easily to mobile devices, tablets and things like that, apps, etc. But yeah, I'd say if you want to build a web-based workflow, there are some really great tools to do that. Part of this talk will apply, not all of it. And given this was a very time-constrained talk, I can't really cover the two. But yeah, you're right. They're both very, very valid approaches of addressing the same problem. One of the things that we emphasised here, really, in terms of doing things locally, is that lots of people have their own tooling, and configuring that on a remote machine is often a little bit trickier, and there are a few more hurdles to jump over. And also, lots of scientists or lots of academics I find tend to work with the data itself. So having that available locally and being able to perform actions on that data sometimes can be an advantage.
Do you
but
think you can do that from a web browser?
Sure. Oh, I see what you mean. Have a web browser locally.
So, yeah,
yeah,
so
sure.
It's just local host and then your path to your local directory on your device.
Yeah, sure. But both approaches would be valid. Yeah.
Anyone else?
Yeah. So at Parcel, do you see it being useful if you access to multiple clusters at the same time?
Oh, absolutely. It's a very powerful tool. I've only come across it relatively recently, and it seems like a really impressive, very impressive piece of kit. You can the functions that you wrote. You notice none of them had any explicit instructions on where to run. It only said I run somewhere else. And then in another part, you can give them hints on where to run, and then separately you configure several different places for them to run. So it could transparently be sending off jobs partially to a cluster, partially to the cloud, partially to several different clouds. It can also manage sort of fairly transparently some file transfers between those different places. So it really is a very powerful tool.
Okay, I think that's one random one. A couple of years ago, this idea was pitched at the university I used to work at. It was rejected on the basis of it hated so much from the users, they would submit ridiculously sized jobs, not realising the gravitas of the submission they were putting in, when there was just a little drop down, click OK, done. You lose all of the complexity behind it, and even the size of the job sometimes people don't realise that. But your massive endeavour is to shift a couple of gigabytes of data around.
Yeah, sure.
Is that concern at all? You have the ones that say, oh, easy now, that's a bit, ooh.
Yeah, I mean, to me, that's something that should be managed on the cluster level anyway. This isn't, to my mind, this isn't the right place to handle that problem. We could, if you were building an application with these technologies, you could very easily put something in place to prevent that on a local level, or to have some sort of central server that's managing some sort of the amounts of stuff, or even just a file on the cluster that you're locking, that's doing some counting. To my mind, though, that's not the right place to solve the problem, and I'm not sure really that it's actually any better that you tell people, hey, just because the process of submission is more complicated, they're not going to have a better appreciation of what's going on, to my view.
Okay, let's continue these conversations over coffee.